Helium is something of a bizarre contradiction here on Earth. Although it's the second most abundant element in the universe as a whole, combining with hydrogen, the most abundant, to form an estimated 99.9% of all known matter that's out there, helium is becoming increasingly rare on this planet. The main reason for that is because it's currently an almost completely non-renewable resource. There are a few issues at play here. First, helium is extremely light, and helium atoms don't easily bond with others. This means that once helium gets released out into the atmosphere, it just rises and rises and rises until it escapes Earth entirely and siphons off into space, lost forever. Clearly, that's not an ideal situation already if we've come to rely on steady helium supplies, which we have done. But it's made worse because new helium generation is a slow and unlikely process as well. While much of the helium away from Earth forms inside of stars where nuclear fission creates it from hydrogen, the helium that's present on Earth is buried deep below the surface of our planet. It's a product of natural radioactive decay, but here's the catch. Because the process needed to create it can take millions of years to unfold. So now we have a product that takes ages to form, but one that also quickly escapes once it has finally been tapped. Lastly though, while helium can be mined, and if that mining is done efficiently, its escape can be prevented. It takes a very particular series of geological conditions to 1. Trigger natural radioactive decay and therefore create helium in the first place, and 2. Ensure that the helium that is created remains trapped under the ground at least long enough to be mined by us, rather than escaping of its own accord. As such, the locations on Earth that boast an abundance of buried helium are few and far between. This stuff is volatile, it takes ages to form, and the conditions for it to form are uncommon. Given all the requirements then, it's perhaps little surprise that the availability of helium has historically been quite unpredictable. But still, why is this such a problem? Wouldn't a helium shortage simply mean fewer balloons bouncing around the place? Well, yes, it could mean fewer balloons. But the unique physical properties of helium mean that it's more than just a party gimmick. Among helium's most interesting and therefore most sought-after inherent properties are the fact that it's the second lightest element behind only hydrogen. It isn't flammable like hydrogen is, and arguably and most importantly of all, it's an immensely effective cryogenic fluid, which means that in liquid form it's extremely cold, which has important scientific applications. With this in mind, helium has come to be essential in labs today and in specific pieces of lab equipment. Those cooling properties, which mean that liquid helium is almost as cold as outer space, is invaluable in the healthcare industry, for example, where they're made use of in MRI machines. Magnetic resonance imaging, or MRI, works through superconductor coils, which create a strong magnetic field. But the science behind them is only possible if the coils are kept cold enough to host the electrical current needed, which is where helium comes in. It's been estimated that almost a third of all helium used on Earth presently goes into powering MRIs in hospitals and labs all over the world. So it's easy to see why a shortage is bad news, given how crucial these machines have become for us. Away from healthcare, other notable machines that use superconductivity and therefore helium, and often lots of it, include the Large Hadron Collider at CERN, which is famously employed to study particle physics, and nuclear magnetic resonance spectroscopy, or NMR machines, which again are used to observe atomic nuclei in subatomic detail. Studying particles in this way has become increasingly important for research in recent years, allowing scientists to understand more about how particle interactions work, and to discover previously unknown particles that give us a better grasp of the universe. But once again, it's a field of research that relies on constant and reliable helium supplies. Thanks to the difficulty in procuring helium then, the cost of it has tended to fluctuate, and sometimes severely, placing yet more strain on research and healthcare. In some cases, it is possible to use a substitute, with many labs reportedly trying to switch from helium to liquid nitrogen for some tasks, which is more freely available and less expensive, although it doesn't offer such low temperatures as helium does. And so it often still isn't suitable or possible to switch to liquid nitrogen without damaging expensive equipment. For decades before now, the world has had the Federal Helium Reserve in America to fall back on, a stockpile of helium that was first started up in the 1920s. But that stock has been gradually sold off over the years, and the reserve would down operations across the early 2020s, creating again massive uncertainty. There are other notable helium hotspots, including in Tanzania and Qatar, but it remains to be seen quite how far these supplies will solve or satisfy increasing worldwide demand. So what does the future look like? That increasing demand is in part due to two growing industries that lean on the world's helium deposits: space travel and quantum computing. The private space firm SpaceX, for example, has used helium to power many of its rockets, while the likes of Google have previously underlined how crucial the cryogenic qualities of helium are to maintaining the superconductors needed for the cutting-edge power of quantum computers. Meanwhile, even before all of the proposed near-future tech and gadgetry is taken into account, helium has continually been used in the production of many of our more widespread devices, such as in some regular computers, cell phones, and televisions. There's no two ways about it. If we want our tech to continue to work, we either need to find more helium or find something to replace it. In an alternate world, we could look out into the solar system and into interstellar space for answers. On massive enough planets, including on the gas giants of Jupiter and Saturn, large amounts of helium remain trapped within the atmosphere by gravity. Then we might simply stop off on one of those worlds to top off our helium tanks, much as we do for gas to power our cars. Or we could pay a visit to the Sun, where naturally there's an almost bottomless supply of freshly fused helium just waiting for us to consume it. But in the real world, these are hardly serious options. Down here on Earth, it's a somewhat unusual state of play then, as human society tries to move away from fossil fuel extraction in general, but with the unfortunate realization that much of the helium that is mined at the moment comes as a byproduct of big companies tapping natural gas. There are precious few dedicated helium refineries in the world right now, so nowhere is truly prepared for the future when it comes to this particular element. And despite some balancing out of the helium market in recent months, some estimates suggest that we could still run out completely of this most valuable element within the next 1 to 3 generations. In this case, despite all of the leaps forward we've made in recent decades, scientists, researchers, medical professionals, technical advisors, and many more besides find themselves in something of a quandary. Helium is needed, helium is rare, and helium is apparently running out. Even when times are good, say a brand new resource is tapped that solves all of our problems in the short term, there always remains the specter of eventual failure looming over us. And if a workaround can't be found, whole industries might be faced with crippling shortages in their supply line, causing knock-on effects throughout society. Hospitals could face growing pressure, labs could struggle to run equipment, and companies could struggle to stay afloat. It may not immediately impact most of our lives on a day-to-day basis. Most of us may only know it as the stuff that makes balloons rise. But that's why scientists are worried about running out of helium.